So if we look here, it says, therefore, so after we know this, the p hat of 1 minus p hat of 2 is going to have to equal the mean of p hat of 1 minus the mean of p hat of 2, which should be equal to just the population 1 minus the population of 2. So this is really the nuts and bolts of what you have to pull out of here, is that in order to find the new mean, you're going to take the population, remember this is the population proportion of one sample minus the population proportion of the other sample. And then to find the standard deviation, we have to find the standard deviation from sample 1. That's what the square root is. This is on your green sheet. And then take find the sample standard deviation from your other one, or what it should be, given that what your population value is. Then you have to square them. Then you have to add them. Then you have to take the square root. So what they do is they simplify it down to this formula that's right here. But this is where it's coming from, is from what we learned back in Chapter 6. And it comes from this formula right here, where P1 is the population. Remember, this is a population, not a sample. If you take a look at this, look what you have here. The difference of sample proportions, this is the statistic, okay? And then here's our formula. Understand? So this is going to be our formula that we get to use, and it's right there on the green sheet. So you just have to plug the values in. You don't have to memorize it. I do not want you memorizing this formula. There's no point. So choose a simple random sample, size n, from population 1 with a proportion of successes P1 are independent, and a simple random sample 2 with a proportion of successes of P2. Notice that for the shape, you're going to check both of them are at least 10, okay? The sampling distribution for the subtraction of the two is approximately normal. The center, you can find the center, and then you can find the spread, okay? So remember, when you check the normal condition, you're doing N1 times P1, and then N1 times 1 minus P1, and then N2 times P2, and then N2 times 1 minus P2, because you have to do it for both distribution populations. You have to do it twice, once for each. Hear me, you must do it twice now, because we have two populations of interest we're working with. All right? They tell you how to find the spread as long as there is no more than 10% of the population condition. All right? So you would check that for both again. The sampling distribution, the difference between proportions. Here's your standard deviation, here's the curve, and here's the mean. They're just giving you a pictorial representation of it. Who does more homework? Suppose there are two large high schools, each with more than 2,000 students. In a certain school, at school 1, 70% of their students did their homework last night. Only 50% of the students did their homework at school 2. The counselor school 1 takes a simple random sample of 100 students and records the proportion that did their homework. School 2's counselor takes a simple random sample of 200 students and records the proportion that did their homework. School 1's counselor and School 2's counselors meet to discuss the results of their homework survey. After the meeting, they report to the principals that the difference between the two is 10%. Describe the shape, center, and spread of the sampling distribution. All right, so they go ahead and check the 10% rule, which is what they're doing here. And each of them are at least 10. The sampling distribution is approximately normal. All right, so on my paper during this section, because you're going to have a plan step, right, and you have to do your shape, right, or you're checking normality here, normal, and you're going to have, I'm going to do population 1 and population 2 then. And underneath it is where I'm going to do my 100 times 0.7, and then 100 times 0.3 has to be greater than or equal to 10, greater than or equal to 10. And then I have to do 200 times 0.5 and 200 times 0.5. And that has to be greater than or equal to 10 and greater than or equal to 10, which it is. So now I've checked that condition in my plan step. That's what it's going to look like. And you're going to have to be able to show that you checked population 1 and then checked population 2. Both of them have to be checked. All right, so they find that then because the shape is normal, then we can go ahead and subtract them. So 70 minus 50 is 20, so that the mean and the difference should be at 0.2. So that's the center. This should be the center. So right now, I have a normal distribution with a mean at 0.20, and I just need the standard deviation that's going to go in here. All right, so this is what I have right now, because once I know it's normal, I can subtract the two and get my new mean. Remember, we can't just straight subtract their standard deviations. We have to follow the formula. So the standard deviation, they do 0.7 times 0.3 over 100. This, to take the square root, they get this 0.058. All right? So this is the sampling distribution. Now, find the probability of getting a difference in the sample proportion of P1 minus P2 that is less than 10% of the survey. So what happens is that here we have this normal curve, and you can denote it normal with a mean of 0.2 and a standard deviation of 0.058. And if they want to know the probability of getting less than 10%, we're going to go over here to where 0.10 is marked under the line. Okay. Oh, sorry, that's not area under the curve. My bad. 0.10 is actually on the number line because this is 0.20. So they go to where 0.10 is on the number line. And they want to know the probability of getting this over here. Well, probability equals area under curve. And if we're on a normal curve, you can convert to a z-score, or we can do our normal CDF with a lower bound of negative infinity, an upper bound of 0.1, because that's where we want it to stop, with a mean of 0.2 and a standard deviation of 0.058. You do that and put it in your calculator, and you're going to get this probability. So what's the probability that they could have gotten less than this from the two surveys? And so they look it up on the table where we did it in the calculator. Does the result in Part B give reason to doubt the counselor's reported value? Well, there's a 4% chance that they could have gotten this difference or something more extreme, because isn't this right here a p-value? Remember that this is also denoting the p-value, because it's the probability I could get this value, which is what I got, or something more extreme, given that this is really true, that the null is true. Okay, so there's a 4% chance. Well, there's only a 4% chance of getting a difference in the sample proportion as smaller than the value of 0.10 reported by the counselors. So I'm going to say that the counselors may not be telling the whole truth.